everyone. Welcome to today's webinar on food safety and environmental hygiene monitoring, hosted by KHB and Tianlong Science and Technology. My name is Kaylee. I'm from Tianlong Overseas Marketing Team, and I will be moderating the webinar today. So as leaders in the IVD field, we are committed to advancing healthcare with a comprehensive portfolio that spans clinical chemistry, immunocyte diagnostics, molecular diagnostics, and POCT solutions. So in today's session, we will be focusing on an important and rapidly evolving area, food safety and environmental hygiene monitoring. We will be discussing how ATP bioluminescence is changing the way we monitor and maintain hygiene in food processing environment. So thank you all for joining us. We are honored to have two esteemed speakers with us today. Our first speaker is Professor Fernando Vasvada, an internationally recognized expert in food safety and microbiology. So Professor Vasvada has dedicated his career to advancing rapid methods in food microbiology, and we are honored to have him share his insights on environmental monitoring and the role of ATP bioluminescence in sanitation and hygiene programs. So hi, Professor.
Hello, Kaylee.
Hi, great to have you here today. So would you like to say hello to our audience?
Yes, definitely. Good evening, good morning, everybody. Welcome to the webinar. I want to thank Tianlong team for inviting me to present this webinar along with them. And we're looking forward to the excellent program. After the presentation, we will have a Q&A session. So I'm looking forward to have a little more conversation with you. Welcome.
Yeah, thank you, Professor. To ensure a smooth experience without any internet disruptions, we will be playing a pre-recorded video during the presentation part, and then we will go live at the Q&A session. So if you have any questions during the presentation, please feel free to submit them using the Q&A button at the top of your screen. And if you are accessing the webinar on your mobile phone, the Q&A button will be at the bottom. And your inquiries will be addressed during the Q&A session at the end of the presentation. Now let's get started with the professor's presentation.
We are going to be talking about environmental monitoring for food safety and quality assurance, particularly the role of rapid hygiene monitoring using ATP bioluminescence. By the way of introduction, more than just Kelly mentioned, I want you to know that my career has been in education and training and extension, and I've been working on food microbiology, especially rapid methods and automation in food microbiology at University of Wisconsin River Falls. After the university career, I joined the Food and Drug Administration as an ORICE fellow, and my job there was to start a Food Safety Preventive Control Alliance. This was the body started in response to the Food Safety Modernization Act that passed in 2011, and the idea was to help the industry implement the new regulation. I've been trainer of the trainers and the lead instructor for the Preventive Control Qualified Individual course, and I'm also lead instructor for the International HACCP Alliance or HACCP courses. I've done the workshops, seminars, lectures all over the world, and particularly last 3 years, we've been doing more and more webinars by online so we can reach more people and educating them about the different topics. Okay, so our main objective today is to do the brief review of current food industry situation, new regulatory requirements, and the role of hygiene in food safety assurance. We will discuss environmental pathogens, environmental monitoring, and implementation of the FDA's FSMA regulation. Finally, we will discuss the role of ATP bioluminescence-based method for rapid hygiene monitoring and verification of cleaning and sanitation. And after following this, we will have a detailed discussion of biolim system that Tianlong is introduced. Okay, so this is our agenda. After a brief introduction, which we almost done, we will talk about the food safety, environmental pathogens, and FSMA. We will discuss the cleaning and sanitation, environmental monitoring, some details, because this is the context which we need to have in order to justify why we want to use the rapid methods for sanitation verification. And then we'll go into the discussion of ATP bioluminescence method for verification of cleaning and sanitation. And finally, end with the brief summary. Okay, so in recent years, food safety is in front center worldwide because we have had a lot of outbreaks of illness and the recalls caused by the contaminated food with foodborne pathogens such as Salmonella, E. coli 15787, and Listeria monocytogenes. We have a regulatory framework worldwide that is changing our focus from reaction-based system to prevention-based system, and the new regulation now require us to do the risk-based hazard analysis and preventive control for mitigating hazards that we have identified. We have higher expectations. FDA and regulatory agency have higher expectations, and we are putting more emphasis on GMPs, sanitation control, and environmental monitoring. In spite of this, we have had, when FDA comes to inspect the food processing facilities, they're finding a lot of non-compliances. They're issuing 483, which is the regulatory form that tells you what they found when they come to inspect your plant, and then warning letters if you don't address those issues. And finally, FDA started using the whole genome sequences technology to connect the outbreak investigations with the isolated strain from the food factory. There is a global emphasis on prevention-based approach of food safety assurance, and we are doing that. We know that every year, more than 600 people fall ill because of the foodborne illness, and 422,000 people die worldwide because of this contamination. Food safety issues impact healthcare systems, trade and tourism, and damages economies. The unsafe food costs around $95 billion in lost productivity each year. Indeed, there is no food security without food safety. Food safety, environmental pathogens, and FSMA. Food safety issues, as I mentioned, are a major concern to food industry worldwide. And in response to this concern, the industry has changed the focus from quality control and quality assurance, or TQM system we used to do, emphasizing food quality, to focusing more on the food safety. We are implementing GMPs, SSOPs, and HACCP-based system, and they all require some microbial testing to prove to people that our facilities are clean and we don't have a microbial contamination. Finally, we have some private industry scheme, global food safety initiative schemes such as SQF and VRC and FSCC 22000. These schemes have a requirement for the HACCP-based controls of hazards, and they also emphasize sanitation and environmental monitoring. So, in spite of all the emphasis we have on food safety and we have new systems in the industry, we have a incidence of contamination, and when FDA comes to inspect the food industry plants, they find out that there are many violations, and the citations deal with the GMPs and sanitation. They swab the food plant environment, and samples from the food plant environments are found positive for pathogen, including Listeria monocytogenes, Salmonella, Chronobacter, E. coli, etc. Also, the finished product survey for microbiological contamination have shown positive samples with the foodborne pathogens. FDA, when they find a positive swab or sample from the food plant environment or the food product, they would do the analysis, and they find out that the same strain of pathogen is existing over multiple years. This indicating that the presence of a resident pathogen is there, and also there is a harbor site in the facility. FDA is using whole genome sequencing technology to connect the isolate from the food plant environment with the clinical isolate that caused the outbreak. Okay, so in last about 10, 15 years, we have a lot of emphasis on the food safety. We have done a lot of investigation, industry and the regulatory agency as well, and we have learned a lot of lessons. One of the important lessons we have learned is the most failures that we have are not caused due to the inadequate processing or failure of CCP. Rather, inadequate cleaning, sanitation, and the lack of attention to established sanitation processes or human error are major factors linked to outbreaks of illness and or recalls. Food processing environment is an important source of pathogens, particularly in the ready-to-eat food plants. We're focusing on the prevention-based regulations and the industry food safety management systems such as SQF and BRC that I mentioned. All these things are emphasizing implementation of GMP and HACCP and also requiring environmental pathogen monitoring. Industry, particularly the meat industry in the United States, have emphasized seek and destroy method. And for last about 10 years, there is an emphasis on developing what we call food safety culture. As a matter of fact, when FDA inspector is inspecting a plant, they are also supposed to look for evidence of food safety culture. Okay. So what is environmental pathogens? Well, environmental pathogens is a pathogen capable of surviving and persisting within the manufacturing, processing, packing, or holding environment, such that food may be contaminated and may result in foodborne illness if that food is consumed without treatment to significantly minimize or prevent the environmental pathogen. In a dry product or low moisture environment, two important environmental pathogens are recognized. This is Salmonella and Chronobacter sakizaki, particularly in the infant formula processing plants. In the ready-to-eat product plant and high moisture environment, Listeria monocytogenes is recognized as an environmental pathogen. Now, the emphasis on environmental pathogens, but environmental pathogen does not include the spores of pathogenic spore formers. Here are some examples of environmental pathogens that are identified from outbreaks attributed to contamination with environmental pathogens. We have hot dogs, breakfast cereals, butter, cheese, cantaloupes, ice cream, infant formula, yogurt, peanut butter, and all kind of things. And mostly we're dealing with the Salmonella, Listeria, Chronobacter, or in one case we have Yersinia intracolitica. But that shows that different pathogen could exist in the foodborne food plant environment, and we need to control them. So it's easy to say that we want to control the environmental pathogen, but there are some challenges we have in controlling the environmental pathogen. Two of the most important challenges are transient and persistent or resident strains of the pathogens and the biofilm. Transient or resistant strain of the pathogens are important for us to know about because they tell us where they exist and what we can do about them or what we should do about them. Transient strain enters the facility, but they do not stay. The regular normal cleaning and sanitation programs would eliminate these pathogens because these pathogens are unable to adapt and replicate, so they would not stay in the plant for a long period of time. They are occasionally found during the routine surveillance of the food plant environment. Persistent or resistant strain, on the other hand, enters the facility and stays for longer time. They can establish themselves in the niches in harborage locations, and the normal sanitation and cleaning program that we have would fail to eliminate these organisms. The persistent strains are frequently found during routine surveillance. So difference is the transient strains are occasionally found, persistent strain can frequently found. And the studies have shown over the years that persistent strain of pathogen can persist in food plant for years and years and years, as long as 20 years, 12 years, 10 years, and then can contaminate the environment or the product. The second challenge we have in controlling the environmental pathogen is the biofilm. Many microorganisms can attach themselves to a surface and produce slime or extra polymeric substance, or EPS, resulting in what we call biofilm. The biofilm protects the bacteria from general cleaning and sanitation efforts. And actually, if the organism is present in the biofilm, they have increased resistance to antibiotic agent, and they have increased tolerance for sanitizer. So, for example, if the Listeria is existing in the biofilm, it might require 10 to 20 times higher concentration of sanitizer than what would take normal. Environmental pathogen and some spoilage organisms such as Enterococcus and Pseudomonas, they can form the biofilms, and these mixed biofilms are very important cause for contamination in food plant environment. The biofilms form in the harbor site and growth niches in a food processing plant, and we need to control the biofilm if we're going to have a control of the environmental pathogen. Okay, so let's talk briefly about the Food Safety Modernization Act. This is the most important changes in the food safety system or regulation in the United States in over 70 years. The FSMA has been implemented since 2016, and as I mentioned to you, there's a lot of training going on about how to implement the FSMA requirement. It is a risk-based, comprehensive, and it applies to domestic as well as imported foods, and it is a comprehensive. That means it goes from farm to table. The FSMA confirms the industry's primary role on food safety. When the food safety problem arises, the person responsible or the entity responsible is the processing facility that produced that food and nobody else. It focuses on prevention of hazard instead of responding to food contamination, and then it increases the awareness of and emphasis on the role of hygiene in assuring food safety. This is an important regulation, and sanitation and environmental monitoring is an important part of the preventive control regulation. Okay, so speaking of the preventive control regulation, one of the FSMA rules is what we call hazard analysis and risk-based preventive controls for human food, or PCHF. It is shortened as a preventive control for human food all the time. This rule requires industry to do the risk-based hazard analysis to determine significant hazard that would need to be controlled. Once the significant hazard has been identified, the industry would need to identify preventive controls that will control the hazards. Sanitation control related to cleanliness of food contact surfaces as an important preventive control, and this requires monitoring, correction, and verification. The environmental monitoring and targeted testing are also part of the control that regulation requires for you to do in order to assure food safety or safety of the food that you produce in the facility. Okay, so now let's switch our discussion to cleaning, sanitation, and environmental monitoring. Cleaning, sanitation, and hygiene is very important. It has always been important, but we find a lot of problems here. There are some key issues impacting sanitation related to food safety. First of all, we have low moisture and dry product processing ready to eat products. For longest time, we thought that low moisture product don't have any contamination problem, but we are proven wrong with the salmonella and chronobacter contamination. Ready to eat products, particularly dairy meats, processed meats, dairy products, cheese, we have had a lot of outbreak of illness and recalls. We know there is a problem there. One of the main problems we find out is it's the insufficient cleaning and sanitizing programs. A lot of industry have a SSOPs, but the implementation of SSOPs as a part of the prerequisite program for HACCP may not be adequate. Also, there might be improper chemical use. What sanitizer, what chemicals you use for the cleaners, and how often and how do you do that? That requires some training, and since the workforce is transient, we might have a problem there. One of the major problems in the food processing facilities, at least in the United States, is the poor sanitary design or hygienic design. We have a lot of legacy plants which are in business for 40, 50 years. They're getting old, the equipments are old, and it's hard to clean. There's a lot of damage, wear and tear of equipment or facility. And then when people do the repair, those are incomplete or temporary, and that does not prevent the contamination. One of the main issues is the lack of accessibility for cleaning. If you cannot access the equipment, if you can't tear apart completely, you cannot thoroughly clean that. And what that leads to, if you can't clean the equipment adequately, it gives you the ecological niche and harborage, and usually it is because of the biofilm, so you have to control the harborage in a biofilm. One of the things the industry has done in the last 10, 15 years is use hygienic zoning and environmental pathogen monitoring that we'll talk about a little bit later. And then training is emphasized in all the schemes, food safety management schemes that we're talking about. Okay, as we mentioned before, sanitation preventive control is related to the cleanliness of food contact surfaces. It's an important preventive control, and it includes enhanced cleaning and sanitizing procedures. It deals with prevention of cross-contamination or cross-contact of allergen. It requires monitoring, corrective actions, and verification. And it also involves a comprehensive environmental monitoring program. What about sanitation verification? Well, verification includes activities that demonstrate that sanitation program is adequate and is operating as intended. So verification deals with how we implementing the system that we have designed. Methods used for verification can vary significantly depending upon the food, the facility, and the relevance in the food safety system. For example, you can verify sanitation by visual check or measure the chemical composition. Another common way of doing this is microbiological testing, and you can do pathogen environmental monitoring as a part of the microbiological testing, and record review. In recent years, ATP bioluminescence provides important tool for rapid hygiene monitoring and verification of cleaning and sanitation. So what about hygienic zoning and environmental monitoring? Well, hygienic zoning is designed to prevent cross-contamination and cross-contact. It deals with dividing a factory into different zones from non-manufacturing areas to basic GMP areas to transition area and primary pathogen control area. If you are producing sensitive food products such as infant formula, then you also have to have a high hygiene area. Environmental monitoring is used for verification of sanitation preventive controls when used to control environmental pathogens in ready-to-eat products that may be exposed to the environment prior to packaging. Here we're talking about salmonella, chronobacter, and Listeria monocytogenes. Hygienic zoning, usually we have a factory divided into 4 zones: zone 1, zone 2, zone 3, zone 4. Zone 1 is the product contact surface. This is very important. Zone 2 is the adjacent area, that is the surfaces near to the product contact. Zone 3 is the outer area outside the ready-to-eat room, and zone 4 is the other areas such as the offices, locker rooms, that kind of thing. Now, when we do the swabbing, most of the industry would do the swabbing in zone 2 and 3, because if you find the pathogen in zone 2 or 3, it will be in zone 1, and it will likely to get into the product contamination. But FDA expects industry environmental monitoring programs to have sampling in zone 1. If you don't have any zone 1 swabbing, FDA would question that, and you would have to explain why you're not doing that. If you swab zone 1 and find the pathogens, the detection of a pathogen in zone 1 requires immediate action, as product may be contaminated already. And then if you do the hygienic zoning, you realize it is important in environmental programs for ready-to-eat food plants in particular. Okay, so what are the objectives of the environmental programs? Well, some of the key objectives are to verify that hygienic zoning efforts are effective, and to detect environmental niches and thus target corrective actions to remove resident strains. Another objective of environmental monitoring is to prevent cross-contamination or recontamination of products and prevent microbial harborage. To develop and design environmental monitoring program, this is a different topic for the entirely new webinar, or we teach a 2-day short course on environmental monitoring. But the key aspects here are each facility is different, so you have to develop the environmental monitoring tailored to each specific facility. It may include pathogen testing, or it may include the indicator organisms such as coliform and Enterobacteriaceae. One thing you want to make sure that if the environmental program, monitoring program is useful, it has to diligently try to find the organism. It will support search and destroy strategy that I mentioned to you before, that particular meat industry is using. And then key consideration in the environmental monitoring program is consider the plant layout. Separate the raw area or pre-processed area with the ready-to-eat area or post-kill step. Airflow, personal traffic pattern, sampling strategy and plan, and the data recording and monitoring. Again, environmental monitoring program, developing that program, where to sample, how many samples to take. That's a detail subject for different activity. Okay. Now let's come to our final discussion of the ATP bioelimination method for rapid hygiene monitoring and verification for efficacy of cleaning and sanitation. As I mentioned to you, control for human food regulation requires that you have to do a sanitation control if you have a significant hazard that requires control. There are several different ways that you can verify cleaning and sanitation. Visual inspection is the easiest one, and that's the only thing required by the law. But visual inspection is very subjective. Chemical cleaning conditions, such as amount of sanitizer you use, or the water you use, or temperature of water, these are all automated, monitored. It is a better thing to do, but it does not give you any idea about what is the adequacy of cleaning. Microbiological testing is the gold standard. We can test for indicator organisms such as coliform. We can test for the spoilage organism such as Pseudomonas or total plate count, or we can look for the specific pathogens such as Listeria species, Listeria monocytogenes, Salmonella, etc. We can use the conventional methods, which takes maybe 2 or 3 or 4 days, or we can use some rapid method, including some molecular methods such as PCR. But all these methods are tedious, time-consuming, material and labor-intensive, and more importantly, they get the results in a retrospective fashion. That is, the product is already processed and stored, and you get the results 2 days later. If you find the problem, you cannot take any preventive action at all. Thus, there is a need for rapid method of hygiene monitoring and verification of efficacy of cleaning and sanitation. Rapid hygiene monitoring using ATP bioanalysis-based method has been available for more than 30 years. There is a lot of development, and the technology has changed, making more user-friendly, faster results, and electronic data handling. So we have come a long way as far as the ATP bioanalysis methods are concerned. Just a brief review, and I would let the details discussed by in the later part of the webinar. But ATP is a high energy compound found in all living organisms. So all plants, all animals, including fireflies, have the ATP. When luciferase enzyme reacts with the substrate luciferin in presence of the ATP, the end product is the light or bioluminescence. The light intensity of bioluminescent reaction, that's a luciferin-luciferase reaction, is proportional to the amount of ATP present. So if there's a more ATP present, that means there's a more light. And this light is measured using luminometers, and results are reported at RLUs, relative light units. The presence of ATP on surfaces indicate improper cleaning, including the presence of organic debris such as soil, food material, particles, and bacteria. Many luminometer devices and softwares for recording, tracking, and trending of results are available commercially for rapid hygiene monitoring. Details of ATP bioluminescence-based method, as I mentioned, will be discussed in just a few minutes. So what are some advantages of rapid hygiene monitoring? Well, first of all, ATP-based system gives you direct, objective, and rapid tests, less than 15 seconds, sometimes 10 seconds, 20 seconds, depends on the system using. Quick results to monitor and verify sanitation. It is simple, it is effective, it requires very little training, and it gives you the cleanliness measurement and actionable result. That means you can do something about unclean surface right as you find the results. It will help you identify hotspots, hard to clean sites, that is niche development, and high risk vulnerable areas. Immediate corrective actions can be taken, such as recleaning the surface if you find high level of ATP where it shouldn't be. Trending and tracking, so you can look at the data from last week, last month, last year, a particular location, particular factory, and in a timely manner. And then it is an effective and convenient tool for training. One of the things people use, and we have used it many times, is to swab somebody's hand, the worker's hand, and then do the ATP reading, and you will find out that is a high ATP reading. That means hand was not clean. That is and then you ask the person to wash the hand, and then you do the next reading, and the level is way down. It is a very important method to get that they have to have a clean hand. However, the rapid hygiene monitoring using ATP bioluminescence method is not really a test to look for the microbial count or the bioburden. A lot of people misunderstand that. Relative light units you get in the reading of the rapid hygiene monitoring is not same as the colony forming unit. Why? Well, because ATP hygiene monitoring system gives you total ATP. That includes the microbial ATP and the residual ATP. And you don't know what is the proportion of microbial ATP to the residual ATP. So correlation does not occur because in real world environment, there is residual ATP as well as microbial ATP. However, if you got a pure culture, or if you have a pure ATP, for example, you will get a very strong correlation with the rapid hygiene monitoring. So you can do that for validating the luminometer system or look at the specificity, sensitivity, and those kind of things. So rapid hygiene monitoring is not a test for microbes, but it can be used for non-specific bacterial sterility tests. So if you make sterile products, particularly in the pharmaceutical industry, or you make sterile beverages, you can use that, aseptic beverages. You can use this kind of system to measure the contamination or sterility. It can give you presence, absence of contamination in less than 24 hours. In about 24 hours. And then it can also be used to verify cleaning protocol. So let's summarize. We know that about 420,000 people die every year in the world because of the foodborne contamination. There are many outbreaks and recalls that are linked to the microbial contaminant of food and food plant environment. It's, particularly the environmental pathogens such as Listeria monocytogenes and E. coli 15787 and Salmonella are important pathogen here. Food safety regulations such as FSMA and industry practices such as GFSI schemes emphasize hazard analysis critical control point program, preventive control-based approach to control hazard of environmental pathogens. And we have learned that food processing environment is an important source of pathogen. If you control the contamination in the food processing environment, it's much easier for you to control, assure the food safety. And if you make a ready-to-eat plant, ready-to-eat food products in a plant, then FDA expects you to have the environmental monitoring program. Hygienic zoning and environmental monitoring program are key components of the sanitation preventive controls, particularly in the ready-to-eat food processing facility. And many analytical methods, including microbial testing and ATP bioluminescence, are available. ATP bioluminescence-based method gives total cleanliness of surfaces, microorganisms plus the food residue, but readings may not correlate with the CFU or SPC count. So with this, I will thank you for your attention and turn it over to Tianlong for the next part of the webinar.
Yeah, thank you, Professor. Your excellent presentation and your insights on environmental monitoring and food safety are really invaluable. So now let's move on to our second speaker, Dr. Jessica Wu, the product manager at Tianlong Science and Technology. And Dr. Wu holds a PhD in biology from the Australian National University and has deep knowledge in hygiene monitoring technologies. And Dr. Wu will introduce Tianlong's BioLum hygiene monitoring system and discuss how it is used in practical applications. So now please join me in welcoming Dr. Wu.
Hi, everyone. It's a great honor for me to introduce you about our high-performing bio. I hope you will enjoy the talk, and I will be glad to take any questions that you may have about our products after the presentation.
Thank you. Thank you, Doctor.
So now I'm going to talk about our BioLum series, the portable ATP hygiene monitoring system. I will talk from the three components, the background, the product introduction, and application cases. So as Professor Fernando mentioned, food safety is closely correlated with our daily life. So according to the estimation of WHO in 2022, about 600 million people in the world may fall ill after eating contaminated food, and 420 die every year, resulting in the loss of about $110 billion each year in productivity and medical expenses in low and middle-income countries. All of these losses are highly correlated with inadequate cleaning during the handling, processing, transportation, and distribution of food. So because this is the case, efficient cleaning and sanitation for any surfaces that may have contact with food are necessary for preventing food contamination and promoting food safety. Multiple standards and guidelines now have been carried out to verify and evaluate the cleaning efficiency after regular cleaning processes, such as the 3A sanitation standards, the HACCP, and EHEDG. Also, the Food and Drug Administration and the United States Department of Agriculture require that food contact and non-food contact surfaces should be cleaned and sanitized as frequently as necessary to prevent contamination of products. So, for example, the 3A sanitation standards have recommended ATP detection as a routine part of cleaning preventive control program. Also, here shows some research findings that have been proven the effectiveness of using ATP testing to verify cleaning and sanitation. So why ATP can be used as an indicator of improper cleaning and to direct effective monitor of hygiene? Before answering this question, we should know the fact that ATP is an energy molecule which can be found in all living organisms. So in food industry, for example, high levels of ATP can be caused either by microbe contamination or by the presence of uncleaned food residues. So unlike contamination that we're all aware of is dangerous, food debris left in the food processing surfaces is also unsafe, as it can serve as a source for microbial growth, which thus leads to reproduction of microbes threatening food safety. So neither of these debris found on surfaces is wanted, and ATP is a great indicator of the presence of these undesired matters. ATP test is based on the firefly luciferase reaction, which can produce light from luciferin and ATP. The amount of light produced is proportional to the amount of ATP in a sample. In some situations, the amount of light is also proportional to the amount of microbes in the sample. To better display the results, the luminometer transfers the brightness of the light into relative light units, which is also called RLU, from which we are able to aware whether the surface is clean enough and what we should do next to have better hygienic outcomes. So based on the proportional correlation between RLU and ATP, ATP tests are widely used in the food industry for the following four main purposes: to locate potential hazard sites, to validate cleaning methods of routine management, to educate potential users for operational standardization, and to monitor effectiveness of cleaning and sanitation. So apart from luminometer, there are also other methods used in the food industry to monitor the cleanliness of equipment, containers, and any surfaces contacting food. The most frequently applied methods include microbial cultivation, genomic or enologic techniques. However, these methods all require a long time period for target accumulation before detection. And in comparison, ATP testing is fast. It can provide hygiene assessment results within seconds, which is pretty important for industrial managers to locate and fix any high-risk sites in limited times and to reduce financial losses caused by idle plants. The second advantage of ATP testing is relatively easy to use with any other conventional methods. And unlike conventional methods, for example, the cell culture method, where microorganisms require specific conditions to grow, ATP testing can not only perform detection in any operational scenario, but can also detect ATP from non-culturable microbes, or those from unreachable corners. These properties make ATP testing valuable for fast and on-site hygiene assessment. But then again, conventional methods, especially cell cultivation, is still the golden standard of microorganism detection. So in practices, culture methods used in conjunction with ATP tests seem to be an effective way for the periodic validation or identification of ATP sources. And this is also our recommended steps for optimizing the effectiveness of cleaning and hygiene management. That is cleaning, ATP testing, sanitation, and then get adequately cleaned surfaces. Then we had our first ATP luminometer launched in 2009, and now it has been upgraded to the third and fourth version, which are called BioLume and BioLume Pro, respectively. The BioLume product series contains three main parts: the instrument, compatible swabs, and powerful intelligent software, and the two latest versions are our featured products. Here shows the main properties of the instrument of our ATP testers. Benefits from the detection method and the strong manufacturing capacity of Tianlong, our ATP testers can assess the presence of ATP down to 0.1 femmole in 10 seconds with simple touches. They also have large storage capacity, which enable as much as over 250 users to store over 10,000 results. The outstanding performance of our BioLume has also been certificated by AOAC. The detailed information will be introduced later. So apart from the superior performance of all our ATP testers, each version of the BioLume series products also has its own irreplaceable properties, making them applicable for different customer requirements. For BioLume, the compact design and excellent power system makes it flexible for multiple scenarios, especially those with limited spaces and complex external environment. Also, BioLume has an open system, which means it can be capable for ATP swabs from both Tianlong and other manufacturers. This is extremely convenient for customers who have stockpile from different manufacturers. And for BioLume Pro, which is our latest ATP tester, as you may see from the image, it has a more stylish appearance, which enable users to perform operation directly by screen touch. Moreover, it is equipped with cloud-based data management system, enabling users to conduct data management from multiple equipments at any time in any places. The second important component of our BioLume products is the compatible swabs. We have swabs in different forms. For dry surfaces, we recommend to use our ATP Quick Swab. It is a pen-like device which contains all required reagents for detection. So before detection, you just need to take out the swab, sampling in highly skeptical area, install the swab back into the tube, inject preloaded reagent, and then insert into the instrument after a quick shake. Then you will get your result in 10 seconds. The whole process is so simple that even a layperson can master the skill after a basic training. And for ATP detection in liquid samples, we also have two types of swabs, depending on the detection objects. For water and liquid that is supposed not to have any organic matters, we recommend to use liquid swab total to measure dissolved ATP that is free in liquid. While for complex liquid environments, for example, those are for organic matters such as milk, juice, etc., sole application of liquid swab total is not enough. So we recommend to use liquid swab free to be combined use with liquid swab total to exclude the influence from background organisms. In this way, we can monitor the amount of ATP solely generated from microbes. The operational steps are similar and simple as that of the quick swab, as introduced before. So the above three swabs are all for our BioLum instrument. So considering the requirement of either storage and decreased transportation costs in practice, Tianlong has produced an improved surface swab for BioLum Pro. In comparison to quick swab and liquid swabs mentioned above, the leaf-fertilized quick swab contains freeze-dried reagents, which makes it more stable at room temperature and is cost-effective for transportation. And it doesn't affect the accuracy and sensitivity of the results. The excellent performance of our ATP testers has also been confirmed by AOAC. We selected two most commonly used brands for comparison. So according to the AOAC certificate, results of each detection with our BioLum has less variation between each other, and the average result is close to the target concentration when detecting pure analytes with 100 femol of ATP, indicating it has better precision and accuracy than the other two products. Here shows the limit of detection of pure analytes using 4 different ATP testers. So as you may see from the slide, BioLum of Tianlong has lower LOD values, which is much more sensitive than the hygiene monitoring and management systems from A and B. We also look at the R2 value, which indicates the linearity of detection sensitivity. Tianlong also has the best performance. So in order to determine the feasibility of detecting food matrix residues on stainless steel surfaces, we assessed the cleanliness of the surface that was treated with dilutions of 3 pure cultures of microorganisms and 4 food matrix. As you may see from the result, under the dilution of 1 in 10,000, Tianlong BioLum shows rapid and precise determination for both microbial cultures and food debris. And in addition to the excellent detection of performance, our product lines are also stable, where we can see different batches of instrument and swabs have no statistical differences. And for improving the detection capability of our instrument, we also have the Eternal Light H, which is a reusable device for quick and reliable calibration verification. We recommend incorporating instrument calibration into a quality control program to verify that the BioLum ATP continues to operate correctly and is under control. So Eternal Light provides an all-in-one reusable positive and negative cultivation verification. So when by pressing the button on the cap, the Eternal Light will emit a 3-second green light to indicate power on. So it can be used as a positive control when on and a negative control in the off status. Then I will share with you some of the application cases from our real customers. The first is Shanghai Guanshengyuan International Trade, which is a renowned food processing enterprise in China. At present, the company mainly produces and operates 5 categories over 1,000 kinds of products, including candies, honey products, healthcare wines, flour products, and condiments. So before using ATP testings, Guanshengyuan used to conduct necessary food safety detection of finished products. However, during the routine test in April of 2022, the production manager found that E. coli test of several workshops had exceeded the standard for many times in a row. Because of this, large quantities of products were destroyed and the factory faced high economic losses. So they tried to identify the potential high-risk sites using conventional cultivation method. However, as I mentioned before, it cost a long time period. So sporadic food safety indicates still happens during the food processing procedure. So to quickly identify the high-risk sites and to prevent from potential contamination in the future, Guansheng Yuan applied our Bioloom products at sites of basins, bales, operational consoles, etc., of every producing department before production. So this is the overall operational strategy we conduct for Guansheng Yuan. With the help of Bioloom, they have conducted their own disinfective workflow. So after using ATP tests as a routine quality control methods of cleanliness and sanitation, the product qualification rate has increased by 99%. As said by the workshop supervisor, ATP products provided strong support for food safety and promoted the management quality of the production environment. Another example is from Russia. So because of the strong penalties imposed by the state on food safety violation, the food-related industry need to pay great attention to the cleanliness and sanitation of materials contacting food. So since the release of our Bioloom product in 2016, we have built strong relationships with clients across various industries and have over 1 million tests sold. Here shows the rough procedure of preparation and production in a meat processing plant in Russia. So after arrival of the livestock transportation vehicles and before the initiation of meat production, the cleanliness of both vehicles and staffs are first tested to cut off the potential external contamination. And during the production phase, all machines and materials that may have contact with the meat are supposed to be cleaned after each round of production. So several key points are set in the production phase to detect the cleanliness of both machines, such as the slicing machine, sealing machine, and freezers, as well as accessories including the pipelines, tables, and containers. So as recorded by our customers, more than 10 tests need to be carried out per production line per day to ensure the safety of food and working environment. So besides of meat processing plants, ATP tests are also widely used in industries such as the livestock farms and dairy processing plants, where all materials and instruments, including milk machine, milk receiver, pipelines, cheese factories, need to undergo cleanliness monitoring before production. And in addition to food raw materials, any surfaces or liquid that may have contact with products also need to be routinely detected to prevent any potential threats towards food safety, healthcare, and environmental protection. And we aim to actively engage with food industry leaders, offer tailored on-site ATP support, maintain close communication, and deliver exceptional products to our customers, and to expand our collaboration efforts with all stakeholders for enhanced quality control in food safety and environmental monitoring. Thank you, and that's all about my presentation today, and I'm happy to take any questions that you may have.
Thank you, Dr. Wu, for your insightful presentation. The customer cases you shared really helped us understand the technology's impact. So next, we'll move on to the Q&A session. Our team has reviewed and organized the questions. So now let's take a look at the questions. We got one question from Stephanie. I think this question is for Professor Vasavada. So the question is ATP testing considered an acceptable method for regulatory audits, or is it primarily used as an internal verification tool? So, Professor?
Yeah,
Hi, Professor.
okay.
Hi.
Thank you, Stephanie. Whether you can use ATP as a regulatory audit, it depends. If you're looking for the environmental pathogen, though, you will have to do the microbiological test. But what ATP does is gives you a quick indication if you're done a sanitation adequately or not.
Okay, thank you, Professor. Hope the answer is helpful. So our next question is can ATP detect different types of microorganisms? So I think this one is about Tianlong's Bellum product. So let's hear from Dr. Wu for this question.
Yeah, so our current tools are for detecting the whole set of microorganisms, and it cannot distinguish between different kinds of microorganisms. But we are gradually developing new swabs that can target the key pathogens, such as E. coli, in the future to satisfy our customers.
Okay, thank you, Dr. Wu. Now let's look at the next question. A question from Kathy is, what is the recommended frequency of calibration of Bellum, and how long is its service life? So Dr. Wu, would you like to share some thoughts?
Yeah, sure. We recommend to do the calibration every month. However, the frequency is also depends on the frequency you use the bioloom, and the service life is 5 years.
Okay, thank you, Dr. Wu. And some of the questions our team has answered in the questionnaire. And if you have any more questions, please use the Q&A button to submit your questions. We will be waiting for a few more questions just in seconds. Okay, so if we have no more questions, that's all the time we have for the questions today. And if you have any more questions in the future, please feel free to reach out to us through our email or our phone. And our team will get back to you as soon as possible. And also, we'd like to invite you to stay connected with us. Please scan the QR code on the screen to follow us on LinkedIn, where we'll be sharing industry insights, product solutions, and updates on our future webinars. And thank you again to both of our speakers, and thank you to everyone who joined us today. We hope to see you in our next session. Bye, everyone.
Bye.
Bye, Professor.
Bye-bye.